So I have a degree in business, and I graduated. I am actually I was born and raised in Turkey, and I lived there until 2013. And as part of my business degree, I moved to the United States back in 2013, and you know although I was like heavily I was like studying business, I was still heavily interested in management science, like computer management, managerial information systems, consumer psychology, and things like that. And upon my graduation, I moved to the Bay Area, and started working as an analyst, mostly doing experimentation and advanced analytics, starting from Old Navy's this retail company, Old Navy. I started working there as a experimentation analyst, to measure e-commerce business and their creative content. But I've always had this like huge craving for doing more in the design and art disciplines. So while working, I started doing my master's in digital arts, and I that sort of like shifted my career to take a little bit more like data visualization focus. And I've been a data visualization developer and designer for Gap Inc. brands, umbrella brands, like Athleta, Banana Republic, all those brands, for about 3 years now. And I first met with Gray Area about almost like 2 years ago through the immersive program, creative coding program. Then, like last January, I joined the artist program, and I have been an incubator artist with them since last January. And apart from that, I'm also a yoga teacher. I teach yoga and meditation voluntarily, and that's my sort of like giving back to my community in a sense. And I know, like like it's all these like different disciplines, but I actually like to build connections between each and every one of them. And that's like why I really love data visualization, because you can actually like combine all these like different practices and disciplines. And when I have worked and experimented with a lot of tools actually, and I would like to provide some clarity to understand which tool can do what, because I have struggled myself a lot to really like go from A to B. Okay, like why am I doing this? Why am I using this tool? Like there are like many things out there. So yeah, that being said, although like we're going to be covering a lot of different topics, um, I would like you to, like still contribute to the course content if you can, if you think that like if I'm missing something, or if you want to like make your contribution, please feel free to like put that into the chat box, or you can always email me, and like later on we can share with the whole group later on. Um, so before doing anything else, I also want to ground myself a little bit, mentally and physically. So let's just arrive to this space, although it's not necessarily like physical. Let's just like physically, even like let's just um, arrive to our seat, and like mentally, like we are going to be spending 3 hours here. So let's just um, start with the intention of like sustaining our focus for today. So for just for my own understanding and my own reference, I would like to understand how many people are on this call have some sort of background with data visualization. And you can just put it into the chat. Oops. Okay. You don't have any experience. You guys have any experience with Python or data science? Any of you guys, like, what is your background? Like, are you an educator? Are you a journalist? Are you a data science professional? What is your background? A little bit data is some experience with, that's perfect. Oh, we have a Seaborn person, Matplot. Okay, that's great. A little bit of like a mixture, I think. Red Tufty, we're going to be talking about Tufty today. I teach information design. Oh, that's great. Okay. Art studio, that's great. Graphic design. Oh, we have all these like great technology person 533, VR and AR, data analyst, educator, documentation filmmaker. That's amazing. So thank you for all of your inputs. I think that's going to help me understand at least like adjust the course content a little bit. Although like everything is almost structured. Okay, you are a student, that's perfect, architecture and urbanism. So we're going to be touching all of these specific topics, and we're going to be like combining all of them together. But let's just go ahead and talk about the agenda today. So for anything technical, I would say you're going to, build your own kit and or own toolkit and start experimenting with like a lot of different stuff. And hopefully you're going to have a little bit of understanding, like tools and like which tool is serving to which purpose. But in the very first hour, we're going to like dive into all these like theories and like design principles into in data visualization. And then like we're going to cover all these like fundamentals and then characteristics of impactful stories and why do we actually create a data visualization. We're going to get a little bit more intentional about it, and then we're going to dive into the specifics of gathering data, conception, mapping data to visual structures, and then design principles. We're going to talk about Tufty. We're going to talk about visual elements, colors, and graphics, and fonts, and things like that. And then in between all these sessions, we're going to have some exercises before actually like putting everything down into a practice with the computer itself, because I think it's important to first, understand the idea of a little bit more. In the second part, we're going to be talking about the tools, and we're going to set up our development environment, and we're going to, like explore some Python libraries. Specifically for this course, we're going to be focusing on Plotly and Dash, but we're going to briefly talk about some of the visualization libraries that you guys also mentioned in the chat. So the first part is setting up. So I think some of us might have Python installed in our computers, I'm sure, if you're using that. But we're going to be first, how many of you guys have a Python installed environment? Some of you have, some of you don't have. Okay, so I can quickly show you. So in order to download Python, you can see my browser screen, right? Okay. So in order to download Python, you're gonna, you can just type in, in your browser, anaconda.com/products
Why don't you type the link, copy the link, and paste it into the chat so it'll be easier for people to click on it. And we can't see your browser. We can only see your presentation.
So let's just do that. Okay, does this work right now?
Yeah, so just copy and paste that into the chat, that link.
Yeah,
whatever link you want. Okay, there it is.
Then from there, you guys are gonna scroll down to the top, the bottom of the page. And then, yep, you're gonna see this at the very bottom of the page. You're gonna see Anaconda installers, and then whatever operating system you have, you're gonna choose either Windows, Mac, or Linux. So for it will be better for you to choose graphical installer for Windows and Mac, but Linux, there's going to be, I think, a bash code as an option. So you're just going to click on that and start the installation piece. We're just like doing it in advance so that like we're not, getting stuck there. And
is there a terminal command to check if you have Anaconda or which version of Anaconda you have?
Yes, you can. You see my screen, right? You can type in Python, and you will see the version and some details about Anaconda.
Cool, thank you.
Okay. And it's like, if it's like version 2.7, which is, I think, as a similar case for most of the newer MacBooks, you can also change your version settings, but we're going to deal with that a little bit later on. We're just going to be like installing our Python and text editor for now. And in the worst case scenario, if we're running into a lot of technical issues, we can also work with Kaggle. I also provided some resources for us to be able to work in that environment as well. In an online session, Jupyter Notebook session. And I think this is not the case again for the newer version of Python, but if you, down the road, if you're seeing this dialog menu options, make sure that you have this, add Python to environment variables checked, so that you can call Python and Anaconda at your command line. I think we're good here. And in terms of like files that we're going to be using today, again, let's just go ahead and copy and paste this. Oops. So from here, we have our workshop file that we're going to be working off of. And here, you can actually go to github.com, github/ my full name, AYSENURDEMIR / Data Viz Workshop. And then from here, you're going to be clicking on this code button and then downloading the folder as a, downloading the whole file as a zip folder. Okay. So can you give me a thumbs up if you guys are already done with starting to include? Yeah, okay. GitHub, thumbs up, yay. Okay. Who, like, are there any people who are, okay, thumbs up coming. Any people, like any of you are having problems? You can put it into the chat or unmute yourself.
Hey, Akshay, did you say to download the zip? I missed that bit. Sorry.
Yes, download the zip.
Okay.
Yeah. Okay. So in that zip folder, what you're going to be seeing is, required packages for Plotly and Dash, which we're going to be installing them later on during the class. We have some Plotly sample codes and some Dash templates and some list of public data sources and some data sets that you can actually use to start tackling your data visualization project. List of cool color tools, list of font sources, list of tools for choosing charts, visual maps, data visualization tools, and sample data sets to work with. You can explore them later on, but I can, I will show a few examples down the road as well, but everything is in the text format, text file. So after the class, you can have all these sources that you would like to refer to. So I think we are good there. I think everyone is done with downloading that workshop file. Okay, great. So let's just, without any further delay, let's just start. Let's just make this a little smaller. The first piece, which is the theory. So what is data visualization? Let's just start with a very fundamental philosophical description. So in its very simple terms, data visualization is the graphical representation of information and data. And it is a technology that provides an accessible way to see and understand trends, outliers, and patterns. The first data visualization has its formal roots from 2nd century Egypt, I think. It is a very old way of encoding the data in columns and rows to help with navigation. It catalogs the astronomy, as you can see here. But then more moving to a little bit like to modern data visualization. Of course, it's a very old practice. People have been organizing information since the beginning of time, since we know like that the all these like written texts are there. But of course, we have a little bit of like modern way of looking at things, and first foundations was actually started or invented by French philosopher Descartes back in 18th century. He found the Cartesian coordinates, which is, like you have like this X and Y axis. And that was technically the foundation. That was like one of the first building blocks of fundamental new modern data visualization. Of course, in time, data visualization started becoming a little bit more scientific. And you can actually see these very old examples from, 20th century. In the left-hand side, we have these, we have this like beautiful infographics, I would say, that has multiple circular area charts where it compares months within certain categories. You know, like first, like in the first tile, it compares like cities versus rural. And then in the second tile, sorry, in the first tile, it compares cities and rurals in terms of the diseases of the nervous system. And in the second tile, it looks at circulatory system diseases. So it's like really good way of like cataloging and like categorizing the data back in that time. And on the top, we also have this histogram between years. We have this shared axis, and it has a distribution of deaths among different age groups. So, you know, like as you are moving towards the 21st century, like things are starting to get a little bit more scientific and a little bit more sophisticated to understand what's going on with the information. And on the middle, at the middle, we have this Dubois. I think I looked up the pronunciation of his name from Google, because I was pronouncing as like I was pronouncing as Dubois, which is like a French version of drink, I guess, which is not correct. So anyway, he actually has this very artful way of removing misconceptions with statistics, and he has a lot of work around like you know, like racism and Black people rights and movements and things like that. And he says that, you know, like he really wants to give people a systematic and compact form so that, you know, like other people can understand the conditions of some minority, like the group, like the minority groups. He has a, I think, very cool book called Data Portraits, Visualizing Black America. And although I don't really want to like get too political, the illustrations themselves I find very beautiful and artistic. And probably he used just pen and pencil, you know. We're going to be diving into all these like sophisticated tools, but I think his work is a really good illustration of what just simple creativity with working with colors and lines and things like that can create in terms of being impactful, you know. And of course, we have an illustration from Tufte as we're moving towards the 21st century. So let's just start talking about the characteristics of impactful stories. You know, to communicate information clearly and efficiently, data visualization uses statistical graphics, plots, information graphics, and other tools. And you know, like with all these elements, you know, effective visualization on purpose is actually providing some data and evidence for people to build different pieces of the puzzle together, if that makes sense. So, you know, like visualizations help people to build causality, help make some comparisons, understand different relationships, similarities, and look at specific measurements and all these things that is coming with the idea of organizing the information. So I broke down the course, this impactful characteristics, into 4 separate components, and we're gonna follow that structure, and we're gonna build things on top of one another. But obviously there are 4 main components of an impactful data visualization. One being that it's intentional, it's functional, it has a reason that it's being built, it has a story, it's interesting, it's appealing, and the data itself is trustworthy and it's it's solid, you know, and on top of everything, it's aesthetic and it's beautiful and it's just you know, giving you a certain feeling while looking at it. So I think this is a good example for well, let's just start, because it actually looks at some certain trends in a story. And you know, I'm just going to quickly show you this because we're going to be looking at a lot of different examples today, but this is a risk visualization for palm oils industry. And you know, like when I was just like reading an article about like why people are not necessarily like responding to all these like COVID data visualizations. And it was just creating this hypothesis around the fact that it's not being supported by stories, photographs, and numbers or like evidences that are driving the narrative of the story, right? So I think this is just like a good example of like where we can get to with some of the things that we're going to be talking about. So it has a, you know, like it's a it has a lead that it starts with, like it talks about the story. It has a photograph reference, and then we have this network visualization that that's like technically aesthetic and shows the relationships between different regions of where palm oil is being sort of fetched. So I think, you know, like we're going to be looking at a lot of different examples, but so I think it's just like helpful to remember that like throughout this course, we're going to be looking at just like not necessarily like building a visualization on its own, but we're going to be like talking about like building a story with the data visualization that we have, because I think overall with all these evidence and things like that, we need just like a little bit of sort of like color in order to make that story more impactful. So this is just an example of a very brief pipeline, but we're going to be diving into each step one by one. But we're going to use this as a baseline to start with. So in the very first piece, we have this ideation, and I think any good visualization is very grounded and very intentional. Whenever you are starting building an impactful story, you just need to have that like sort of good purpose, clear purpose, and you know, like in yoga, we have this like chakra system. Like you first need to build your foundation to like, you know, like rise yourself up. So first, get really intentional, get really grounded, understand why you're doing this, and then start building things on top of one another. And of course, we have, after you come up with a good purpose and clear idea of what you're going to be working on, then you get into exploratory data analysis, research. You just like start researching about the topics that's related with that topic. And then you start building your concept based on your research. And then you start moving into visualization and design, and you start, like mapping your data to your visual, and then start like sort of like stylizing what you have. Then with all the components that you have, you like put together a story, you polish it, you maybe test it, you maybe like share it with your friends, with your close circle, and then you publish it. This is just like an example of a pipeline where you have like different time intervals in between different points. But this is like a good starter point. It doesn't need to be like very orthodox. Like you don't have to like fit into this specific structure, but it can provide you a baseline, hopefully. So understanding the why, again, as we said before, is very critical, and we're going to be talking about it a little bit more. So, okay. So we say that, like data visualizations need to be purposeful. And we need to understand why. That's why we are saying that it needs to be purposeful. Because by their nature, data visualization is actually a model. So, any visualization is a model. This is a great book that explains the philosophy of data visualization. I highly recommend if you want to explore a little bit more humanistic side of data visualization and like understand the why of it a little bit more. It's from Truthful Art by Alberto Cairo, and it says that visualizations are models, and we humans are using models for perception, cognition, and reasoning because our limited brains are just incapable of understanding the reality and its complexity. And of course, some models are better than others in explaining, in giving content, being more truthful, being more accurate, informative, and understandable. So if we say that data visualization is a model that describes, explains, or predicts something about the nature, then we need to build more truer models. That's why we need to understand why we are building this. But of course, building truer models is a challenge in itself, because obviously, specifically during these times, we are bombarded with information. We are living in a information overload, specifically during these COVID times. Everything is sort of like happening in a very mental plane for a lot of people. So how can we actually be truthful? So I think one of the best fundamental thing to remember and come back to is that knowing that we're not going to be 100% truthful in any point in time. Specifically speaking about statistical terms and data science, we always have a room for that error. And knowing that, keeping an open eye on that is very essential, I think. So this graph is actually something that I love and give example in every point in my life, that you have this like interval where you have absolutely untrue on one side and absolutely true on the other side. And, you're just like with anything, anytime you're trying to build a model, you're trying to approximate towards the truth a little bit more, rather than just like trying to understand based purely on guesswork. And it's all about I think, with experimentation, you're getting to like getting closer to truth a little bit. You can create like parallel lines, and you can like, like there's art, you can experiment to like get closer to the truth a little bit. Like there are all these things that we can actually experiment with to understand the what's unknown. But knowing that we are not going to be truthful 100% is one big essential thing. And then the second thing is self-deceptions. Of course, like we want to like understand the truth. Like our beautiful brains wants to understand the truth, but also it is conditioned to keep us alive, right? We have all these like survival mechanisms that is like trying to understand like what's going on, but sometimes it is very deceiving, right? Like sometimes we have all these self-deception tendencies that we create for ourselves. And there are like many of them, obviously, but specifically for data visualization, it's like in all aspects of our lives, we have all these like self-deceptions. We have, specifically for data visualization, we have paternicity, which is our tendency to find patterns in randomness and noise. We look for patterns. Sometimes specifically, it happens a lot in data science that you actually, like overlook for patterns. And sometimes you have a tendency to find some patterns in randomness and noise. Then you start, like after you find some patterns, of course you start, like building some cause and effect explanation for your patterns. And then you turn them into these like biases where like anytime like there's an attack to that belief, it might feel very personal because we already like identify with that idea, if that makes sense. And it's a very, like nowadays it's a very popular like mindfulness concept, but it's actually very true. So it's specifically if you're dealing with a lot of like sensitive topics, like political topics, activist topics, and things like that, it's important to, understand those patterns and, like understand if I'm like overfitting, if I'm trying to find patterns and things like that. Do I have any like contrasting, like counter arguments that I can refer to? So it's very important. It's very important to, I think, check in with yourself. And I think what is a way to check in with check yourself on those? I think, becoming an aware, now that like I shared with you, I think it's just like knowing gives you some sort of like awareness, I think. And also like before starting with anything, like slowing down, getting more intentional and like really like looking back, why am I doing this? Of course, you can always like, you're welcome to sort of continue working with some patterns and noises, but it's a personal choice, I would say. But I think getting intentional is pretty important. Specifically, we have a professional life. I'm sure like people are dealing with a lot of like confirmation bias in terms of reading data and understanding data. And also another big component to build truer models is to avoid oversimplification. We always say that, like design is like simplifying, but not necessarily it's the case all the time. We need to sometimes, we need to just like provide clarity, that's for sure, but it's not always about reduction. We can always, it can be about augmentation, where we create more context, not necessarily just removing, but bringing in some elements that might be missing from our models. And in order to do that, like explore your, like we're going to be talking about it a little bit more, but really exploring your information in like multiple levels and like compare your data to other variables, build relationships, find causations, correlations, and you don't have to visualize them all, but you can just bring in some context with different visual elements. So for the first exercise, I would like you to generate some free-form ideas, and these ideas can be centered around something that you want to understand more and like build more truer models on. I think in terms of time, we are a little behind schedule, so we're not going to be spending too much time. Just for 1 minute, just like think about something that you want to understand a little bit more, and that's something that you want to visualize. And you can put in your ideas to the chat and share with anyone else, or you can just like take a note and like, but like think about it for a moment. Come up with that visual mental exercise. We're going to be having a lot of like small exercises like this that are being built on top of one another. So it's important to, engage with those, I think.
Do you mind repeating the question one more time?
So just like generate some free-form ideas about data visualization, like something that you want to, find a topic that you want to understand more, and something that you want to build visuals on. It's free-form, there is no limitation. Just like think about a few of those, and now we're going to move into the next piece. So in the second part, we're going to be talking about information and gathering data. But before getting into, like how to find inspiration, like I'm sure that free-form exercise is just like a little bit of a confusion because there is no constraints to work with. So before getting into, we're going to get into the finding an inspiration for data sets. But I would also like you to reminder the code of ethics for data visualization and for data collection. This might be a highly controversial topic that might require many hours to discuss, of course. But I suggest you to use your own concise, and when searching data, just use your personal code of ethics. And obviously, as a storyteller, oh yeah, nowadays I think everybody has like a similar pattern of like generating ideas, right? Sorry, I think I will not look at it. So obviously, as a storyteller, like as a designer of a visualization, you will still be acting like a filter. So it's important to use your own code of ethics in a sense, not necessarily like following other people or like what other people say. I still think that this is your artistic expression, and whatever comes out is gonna be filtered through your values and your own code of ethics. But of course, inform yourself, understand your own values, even before having things filtered through your own concise. So I just threw some ideas out there where you could find some inspirations from. Your research could be mostly about anything. You could approach your research from different perspectives, from a data journalist perspective, from an activist storyteller perspective, professional, researcher, educator, etc., etc. I also included a lot of a long list of public sources, public data sources, which you can find in your text document, but there is a pretty rich source where in terms of finding public data and using them. Yeah. Another resource to get ideas from is technically your own questions. Data visualization and design could be very introspectional exercise in that sense. And, you can just start with by asking very simple questions to yourself, what interests you, what bothers you, what don't you understand, what do you find really boring, what you don't know, what don't you know, all these things, not necessarily just all the things that interests me, but you can also find some inspiration from all these boredom, ignorance, frustration, I think Darren's, if I hope that I'm pronouncing correctly, it's coming from it sounds like it's coming from a frustration, right? Or there is some sort of desire to know more, so that it's really coming inside and channeled through you. So in the next set of exercise, so first we generated some free form ideas. We're going to be generating some negative concepts. So let's find 2 things that might be bothering you in this point of your lifetime, and 2 things that interests you. And see if you could generate some ideas, questions that data could be helpful to understand that question. And these questions could be political, personal, activist, doesn't matter. Just find 2 questions for bothersome things and 2 questions for interesting things. And you can put them into the chat as well. We're gonna have again 1 minute for all these quick exercises, because we need to move quickly. But you can put it onto chat, you can make a note of them. This is for your own sort of use, but it will be cool to share with the other people on the call. That would make things a little bit more engaging. And so, and of course, moving on to research, to a little bit more into measuring things from a perspective of a measurement perspective. After you come up with an idea or decide on your data set, you start generating some metrics about what you would like to show, right? So I think in Darren's example, he started with an idea, right? And then he started talking about all these metrics that he could generate based on that idea. Visualizing, I think it's the political donations could be the theme of the story, but the emails generated after one political donation per day per politician, putting them into categories. Categories is different, but these how many emails generated per day is an example of performance indicator, and some metrics. And metrics are measures of quantitative assessments that are commonly used for comparing and tracking performance. Average time spent, total sales, total population growth over time, et cetera, et cetera. You can, come up with a lot of quantitative assessments that's going to be summarizing your data. So as a third exercise, you're going to be generating metrics about the evaluation of the last month that you spent, or this could be months or weeks. It doesn't matter the time period, but let's just start getting a little bit using our mental engagement a little bit more. Let's start evaluating, last period, last month, and find few metrics that would evaluate the overall performance of last month. And it's relative to your own values, your own standards, and what's going on with the words. But as you start thinking about these, you will hopefully start getting a little bit more introspective and start trying to build truer models or things that are more important. I think it's important to generate metrics for this one, because we're going to start sketching with this one. So is the question clear?
I'm not super clear on the question. If you could just say it one more time.
So we're going to start generating metrics that's going to evaluate the performance of last month. So we're going to start talking about we're going to start thinking about, okay, how was my last month? What are the activities that I have done? Was it effective? How much time I spent on reading, how much time I spent on scrolling on social media, which is not or all those sorts of things, starting to think about all these measurement mechanisms and KPIs in a sense. Is that clear?
Yes, thank you.
And we are going to have another minute or so. You can also put it onto the chat. But we're going to start talking about the other topic, which is conception. So in the conception piece, we're going to be, that's a good one. I think those are the examples that I would want to see in the chat, if you can. I'm going to check that later on. So in the conception piece, you will start envisioning what you would like to create. And, you're going to start sketching and writing and drafting and understand how your data can come into life. There are two approaches to present data graphically, and both differ in purpose and in design. And it's important to distinguish them from one another, specifically in terms of their purposes, because we can create some confusion and it can be harmful for many different reasons. Because of course, the main reason, again, we keep coming back to this point, but data visualization is building a model, and we want to build truer models, and we don't want to create any confusion when we are trying to be a little bit more artistic. So, you know, with art though, we can go beyond the known, we can go beyond the models and things like that, and we can just like, again, start with experimenting in a different parallel universe. I don't want to use that word, but yeah. So everything is about communicating a concept clearly and to make your intentions clear, so that your work is appropriately evaluated. So here are a few good examples. You know, like on the right-hand side, you are seeing this, I think, equation called Vogel spiral, and it's a model that it interconnects spirals that form the pattern of florets, and you know, like they just like form this sunflower shape, and you know, it's technically all these seeds are representing the most popular trending topics over 70 hours in 11 British cities. But it's really hard to understand what's going on there, right? Like, it's beautiful, but it's not necessarily very informative. Maybe it has a maybe message that all these different cities have all these unique, like, separate identities that forms a bigger one, maybe a bit patriarchal, maybe, I don't know, but it's not necessarily something that I can, oh, like, what is that city that's encoded in blue? You know, it's not necessarily like something that I can use it as a reference to understand like a little bit more in depth. And on the left-hand side, I think this is not like one-to-one comparison, but this is an academic project, and this designer chose to represent the modern art movement in a diagram. And it's technically observing the distribution along time, beginning and, you know, like all these like movements, the beginning, end, and the most important artists that gave them expression. It's still very interesting and fun, and it's sort of like artsy, but it's like when I compare to the other side, you know, like I have all these like labels and categories that's making it a little bit more story, if that makes sense. And the second piece is in concepting, of course, like deciding what approach you're going to be taking. Is it going to be artistic? Is it going to be more of like informative story? You're going to start diving into the information architecture, and you know, EDA is mostly about finding relationships and building the information experience architecture. Note that if you're specifically working with big data and high dimensional data, it's helpful to come up with a concept that has interactivity, because we usually have a intuition for 2D, and we start visualizing all these like high dimensional objects. It gets very confusing for the readers. So, you know, it's helpful to start thinking about all these like sliders, like interactions, slicers, filters that will show your data from different perspectives early on, rather than, you know, introducing them later. There is also a principle called dimensionality reduction in data science, but I don't think we need to worry about that for today. So for narrative structures, another big thing, I think, if you want to specifically make things public and envision your story as a whole, you're going to start thinking about like all these different components of data visualization and storytelling. You're going to have probably a lead, the most important information, who, what, where, when, why, who. You're going to have a body where things starts to peak, you know, like there's going to be a controversial thing, story issue, there's a conflict. And then the tail, which is where the extra information comes into the picture, where you're going to have not necessarily conclusion, but more like interesting and related items. Because I think, I don't think I ever mentioned before, I think good visualization doesn't necessarily make conclusions. It's helping you to explore more in that area. It's helping you to generate more questions. It's in a sense, it's like confusing you more when trying to be a little bit more truthful. Again, I don't want to get too political, but I just solved this and I thought this is a great example to show you in terms of a story. This is a New York Times article, and I included the link in the presentation, but as you can see, it has as a lead, and then like around the middle, it starts peaking, and it starts like all these, like coming up with like a different, like sort of like other topics to add on, and it's continuous, like it has a great addition, and then in the end it has a bit of a closure, and it's closing. So this is an example of building a narrative structure. So let's just start talking about visualization and design. We are very far behind. So, like after the purpose, research, ideation, and concept, you'll start designing your visualizations by mapping your data to your visuals. But first, we need to understand data and data types. By the way, how are we feeling in terms of timing? Like, are we feeling like we need a break? If you want, we can take a 5 minutes break. We can put it on chat about your preferences. Oops. Or you can unmute yourself. Are we good? Okay, cool. I'm just gonna continue without taking a break then, because I think we're a little, okay, perfect, because we have a lot to cover, and I'm just like feeling a little bit more into the content right now, and I don't wanna disrupt the flow. Good. So again, coming back to the visualization, after the setting up the purpose, research, ideation, and conception, you'll start designing your visualizations by mapping your data to your visuals. And first, in order to do that, we need to understand the data types. So there are many things that you can consider as data, but here are some main ones. Not that, like you can play with everything and you can turn everything into data. So quantitative data is the exact numbers. It's, it's life expectancy, income per person. It could be continuous, which is everything that we can count. Sorry, that we cannot count. And then we can have like quantitative data types. Sorry, I get a little confused here. So it can have continuous and discrete categories, and discrete variables are countable. That can only take certain values. And then continuous variables are just like fluctuating numbers between two presumed points. So anything that we cannot necessarily count that easily. And yeah, and then we have qualitative data, which is anything that we can compare and ordered. It could be below average, above average, average. We can like rank them, sort them. And then we have a categorical data type, which is a nominal way to label and categorize data into groups. As an example, like apples, oranges are like pretty straightforward, but like categories of the world that are grouped into regions, blah, blah, blah. Like you can also, anything can be like actually categorized as well based on their shared characteristics. But you can also, this is a little bit of a detail, but you can also rank categories in a certain way, rank them and sort them, and you can make them ordered data type as well. And this is like the case for mostly for instance, like histogram, right? Like you have all these bins and you have sort of all these ordered data that follows one another, but they are technically a category at that point. And there are lots of different types of data, like fractions, maps, distributions, high dimensional data, written text, network data, mixed data, and all these data can be encoded in different ways. But these are like the 4 main types. So the main important theme that we're going to be exploring here is the visual encodings. So visual encoding is the way that the data is mapped to visual structures, and then, we build those visual structures on top of a screen. So before doing anything else, when you're getting into the visualization piece, choosing the right encoding is the first step to build your functional visualization. Of course, there are a lot of types of encodings as well, but the main ones are X and Y, X-axis, Y-axis, and sometimes Z, especially when you're working with like cubes and high dimensional data. You have size, you have texture, shape, orientation, color. And I've included a lot of like maps into that text file where you can actually use some encoding, like data to visual encoding maps for your reference to understand which data types works which encodings. But for ordinal data types, for instance, you can work with line weight, saturation, brightness. For quantitative, you can work with size, area, pattern, position, text label. For categorical variables, for categorical data types, you can work with colors, you can work with textures, icons, you can encode them in icons and shapes and graphics. You have a lot of different options. And I think it's I don't think like we can ever know if, like I can tell them everything, but it's also like your creativity that's you can also come up with different types of encodings on your own. Again, some of the other encodings that you could use, like shade, you can use for ordered data, you can use shade, you can use shapes, layers, text labels in order to differentiate from one category from one another. You can use proximity between objects. You can use density. This is also specific case for network visualizations, for instance. All these different attributes you can use in order to encode your data. You have a lot of things that you could work with. Data visualization is really mostly about, finding representations of your data, finding visual representations of your data. And you have a lot of representation types, and anything that you can think of as a visual association. I also included a quick map here. I think this is pretty useful. I find it very useful. So I have a very simple Excel sheet before I start even initiating a sketch to identify the data types I'm working with, my variables, and then the type of encodings that I can use by maybe, taking this one as a reference. And I also included a lot of different map types that you can actually map things from, or this is also another example that I created. But you can choose, okay, what's my variable? It's a lot of I want to give an example from here. Time spent in transit. What is it's quantitative. How can I encode them? These are my options. What is the type? What is the encoding? I can use color value, so on and so forth. I think hopefully everybody is clear so far, because I think this is the key piece. I hope everybody's clear. I'm not seeing your faces, which is making things a little harder. Oops, and I keep doing this. So let's just look at different visualization examples where we have different encodings. So in here, you can see, the movement is actually an encoding. It's a Venn pattern, and it conveys, the idea very clearly. I think it's pretty simple, great, easy to read, and good example. And then the second piece, I think this is a very funny example of the ultimate data dog, where you have, overrated dogs. This is a perceptual map, I guess. And, it has a popularity, popularity axis, and then the data score axis, and all these different specific breeds are encoded in different icons, of course, and different graphics, and all these colors. I think they represent a bigger category. One is working, sporting, toy, all these more generic parent categories in a sense. Oops. So let's get into information design principles. If you're clear about the encoding types that you could work with. I keep doing this. But before we talk about all these things that can help people, people understand data faster and make things beautiful, I think design is about inclusivity, and you need to know that you're designing for a specific audience. Even if it's you're still designing for yourself. And if you are sketching on your notebooks and things like that, you would still like to have have an understanding when you're referring back to them as a history or as a memory, So I want to cover some basics of inclusivity, which is very critical in terms of accessibility. Again, being very intentional in the beginning of your design and process, like in your designing process, and like providing your context, your like if you have an audience with like age, higher age groups, like elderly population, making sure that you have large targets that can easily be read. You're providing labels and you're describing objects. Specifically, I'm seeing this like not color blindly palettes everywhere. I think it's also very important issue where like, specifically in the companies, like I did not use like red and green together, and like people were like, why aren't you using them? Of course, proper scale, line weight, and contrast for the blocks of your text. These are very important. Like these are like seemingly small, but very important things when it comes to the accessibility of your visualizations. And so we came into the Tufte. Tufte, like I didn't want to get into the visual design principles without talking about Tufte. So he has some rules. Of course, he says that like, there are like some important reminders. This is like a little bit of a conclusion of what he has, but he says that like show the data and like help viewer to think about the substance, the matter itself, rather than the methodology. And I think this is very important to think about too, because sometimes like when the like artistic ego comes into the picture, scientific ego comes into the picture, and you start to like sophisticate things, but it's about the matter, right? Most of the times the visuals, you can make them aesthetic, but first I think making them functional is very essential. Avoiding distortions, specifically when it comes to like maps, I think this could be an issue. Like presenting many numbers in small spaces, it's not a great practice. Making large data sets coherent, to speak to our earlier point, like working with high dimensional data, maybe coming with interactions. Encouraging the eye to compare different pieces of data, especially when you're building narrative structures, giving several details of detail, and being really closely integrated with the statistical and verbal descriptions of a data set. Again, this is coming back to my previous point about that like patternicity, right? That's phenomena called overfitting in data science, where you start like getting a little too deep and you start losing the big picture in a sense. So always like keep checking with the big picture and what's going on, rather than getting too focused in one area. So second piece in visual design principles is we're going to be talking about visual elements a bit. And we're going to be talking about the most critical ones. So the first one is graphics. Again, this will be a repetition, but you could always use text, icons, silhouettes, shapes. That makes your visualization and story a little bit more interesting. Text is a graphics, again, using headers, descriptions, labels, as much as like explaining like paragraphs. It's like you can use paragraphs, you can use like headers, like it's yes, you can maybe like be mindful of like not overcrowding the space, but just like be explanatory and use graphics to add on to that, you know, like creating that augmented experience for your audience. Charts, again, I'm not gonna get into too detail, but I created in the list. You're gonna see a lot of options for choosing charts. You know, like by looking at how many variables, dimensions you have and finding relationships and similarities, you can actually decide on the chart type that you're gonna use. You know, like I think this is a good example where you can start with like what you would like to show. Is it going to be the comparison, relationship, composition, distribution, so on and so forth. You can always like use these ones as a reference. And I think what I can do is I can go ahead and share this one on the chat, so that whenever we're working with our next exercise, we can use it as a reference. Charts, okay, we are here. And again, for charts, you don't have to reinvent the wheel. Bar charts and line charts are very self-explanatory, especially like if you're working with a lot of like interactive components. And very cliche term is that pie charts are actually poor at communicating data. And do you have any idea why is that? Do you know? Like people say that pie charts are very poor. I think you can use them, but you should just be mindful about using them. But do you know why? Maybe you can put it into chat, you can unmute yourself. Is everyone with me?
I heard it's just not a effective way of communicating how much something takes, like in comparison to the other things.
Yeah, certainly. It's something about scaling. You know, it's our brains are not very good at like comparing the size of angles. And you know, like in pie charts, there is no scale, and it's like reading the values, having an accurate information is a bit difficult from pie charts. But I think that's a good explanation. Again, here are some visualization examples. Of course, beyond these charts, we have other types of visuals. Like there are like million ways to visualize data, and one of the main things that I love is like I love like alluvial diagrams, tree maps, network visualizations, and you know, you could find more examples when we're going to be talking about tools, but I want to show you some network visualizations because I think they are important to identify bottlenecks and key players, and you know, to understand the clusters and characteristics and types of relationships. So they can actually do a lot of like predictions, and they are like pretty amazing. But I think you know, like I find a little interesting example, like Shakespeare tragedy, like in terms of like network density, you can actually like build a pretty clear hypothesis, right? Like you can say that Othello is like pretty like highly like sort of like complex, sophisticated story because it has a lot of like network density, like a lot of like different relationship between characters and things like that. And you know, I think like this is just like a different way to look at things a little, like look at things from a different perspective. And in this fourth exercise, that brings us to our fourth exercise, which is sketching. So we're just going to be playing with the idea of creating a graph based on the metrics and theme that you have decided early in the class. So you're going to be choosing your metrics, and you're going to be choosing an interesting, appropriate visualization for your data, your metrics, and find some visual encodings to map your metrics to. Does it make sense? We're just going to be like drawing one thing, one chart or visualization with the metrics that we have. And you can also, like, I don't know if I will be, we're not going to have time to like cover most likely, but I would love to like look at them later on. If you can take a picture and send it to me, you know, I can like send you some feedbacks and share what I think. But, you know, let's just give quick 2 to 3 minutes to sketch something. Is it clear, by the way? Taking that as a yes. Maybe 1 more minute here. You can, it's actually not hypothetical, but could you bring back the examples of data types and variables? Yes, I can. You can just start like drawing them actually, you know, like just quick sketches on a piece of paper. Like you can create like line charts with the activities, bar charts, by like using this one as a reference maybe. Yes, you can. You will. Sure. Just like quickly sketching, you know, like just to mentally engage with it a little bit more. We don't have to know all these like different chart types all at once, because I'm throwing a lot of information at you. You're just going to get used to, by using different tools, you're going to get used to understand like, you know, like which visualizations are working well with one another. But yeah, we're just like sketching very simple exercises now. You can use like line chart, bar graph with the things that you know. You can use pie chart. It's perfectly fine. Okay, so I think we're done with sketching. You can again send it to me, to my email address, and I can look at them. Let's continue with color, which is, I think, the most interesting variable. It's the variable that I love the most, because it could be approached very scientific, and, you know, like certain color combinations can create certain effects. But again, Tufte says that avoiding catastrophe becomes the first principle, bringing color to information. Excuse me. Above all, try not doing any harm. You know, I think the first thing that we're going to be talking about in terms of color is that color is something that has identity, as a visual encoding, and you know, like there's a lot of ways that you can approach to color identity. Is it masculine or feminine? You know, like what is it, like sort of the story that you're trying to tell? And then starting to think about, you know, okay, like what is my story? Is it like more masculine, more feminine? Is it like, what is the tone of it? Is it like serious, playful? Is it modern? Is it classic? Is it youthful, mature? Is it loud? Is it, you know, like what is the energy? Like, is it something more zen, or is it like, you know, like, is it like screaming that I'm here? All these things that you can think of. And I think color can bring a lot of identity to your visuals. And, you know, I love, it's a very fundamental design book. I have a copy of it. It's called Interaction of Color by Joseph Albers, that you can see here. But, you know, like, it's helpful to understand which color combinations interact with one another. You can use this book, you know, like, it's important to understand like that if we use certain color palettes, if we show like one color next to one another, they can make them lose their identity. So I think you can also check, you know, like this book to understand a little bit more on that scientific side. Again, tips for color. Any color can be moved over to a scale. You can give values, of course, and it's a very helpful technique to visualize the ordered data. That's one thing that I can say, is that like if you have a red, you can have different values of that red, and you can visualize ordered data, not necessarily like playing with a lot of like color values. I think that helps soothe things down a little bit more. And then, you know, like, it is helpful to know that like maybe we shouldn't be creating more than dozen colors to encode categories effectively. Like otherwise it's going to be like, oh, like, where am I situation if you like introduce a lot of colors. If you're using red and green at the same time, which I have to do sometimes, make sure to double encode the data that you're working with maybe, you know, like a value, again, for your colorblind audience, or maybe saturation or things like that. Yeah, yes, yeah, interaction of color. And always remember that, you know, red is alarming, green is calm, and gray is most of the time it's going to be a savior. So I mean, I know, like, I think like some of the designers don't necessarily like gray, like specifically, like I think fashion designers, because they think that that it doesn't have any identity. But when you're visualizing data, I think that's the case, that like gray can also, you know, since it's not speaking too much, it can help giving context a little bit more. So whenever you're in doubt, whenever you're like maybe drawing your like axis, maybe when you are like putting labels, so on and so forth, you can always rely on gray. I think that's a good reminder to think about. It's very simple, but it's important in terms of design. You know, again, I think not necessarily introducing a lot of like highly saturated colors is also very important, right? Like, because whenever I think about my audience, I think that, you know, like in order to specifically when you're at work and if you're designing for data-driven decision makers, like you actually don't want to create a sort of like alarming situation. And design has this effect that, you know, it can, you know, it can evoke a certain feeling, of course, as a cliche term. So, you know, it's helpful to keep in mind that if you mute your colors, if you create a little bit of like Zen approach, maybe this is like filtered through me and this is my own perception or my own idea, I think you are giving a little bit of not necessarily like too much feeling, but a room to like read the data in a calmer state of mind. Again, I included some in the color source folder. I include a lot of color tools since I love to work with them. But you can also, like, this is a great tool that you can use. Like, you can add like categories, you can work with saturation, you can work with different values. You can put them on visualization. I also included like many color sources actually, but you can work with like palette generators for your data. These are, again, color blind friendly most of the time. You can work with like Colorbriver. I think this is a like very Tufty style way of bringing color to maps. And then for color libraries, I mean, I can share my link, but I built some libraries in the past for color. And they're all like, most of them are colorblind friendly. I'm not gonna get into detail of those. It's gonna prompt me to use my phone number. But you can also like create your own libraries, and like whenever you need them, you can just like copy and paste your hex values or RGB values and bring them into your visualizations. Fonts, another fun thing. And fonts are very important because when you use them consistently, it unifies messaging and it creates familiarity, choosing highly readable fonts is also very essential. Fonts also have identities, and I also included a lot of source material on how to use fonts in your data visualizations as well. Let's do a quick Zoom chat exercise. I know this is a lot of information, so let's just start engaging a little bit more. So what do you think this font says? What do you think when you see this combination? If you put it in chat, and we can, elementary school, yes. It's actually the font type that I used in my elementary school project, term project. And I loved it because it was the first time that I met Comic Sans. Yeah, kitschy friendly. Yeah, I think everybody loved it when they were in elementary school, and it doesn't diminish their experiences, right? It's just like from a perspective of child. It's not, yeah, everybody. Yeah, if you can include a documentary on Comic Sans, we could use that too. Okay, so what does this font remind you of? New York Times, yes. Book. I love classical fonts. Newspapers, essays, traditional, maybe elegance, I don't know. It's very serious. Maybe not, elegance is not the right word. I don't. Default but formal, paragraphs of text, yeah. I can see that. Okay, where would you see this font? Circus. Yeah, I didn't think about that. In a Wild West indie game, Western restaurants. Yeah, wanted poster, Western poster, yeah. Even I have familiarity as a Turkish person. It's a very global thing, although it's very specific to America. Disneyland, yeah. I've never been there, but probably there are some Americanized way of encoding things. So yeah, as you can see, fonts have a lot of character, and they can, certainly change how your audience is have an initial intuition about your data that you're presenting, right? It's very simple, but very fundamental. Last but not least, this is bringing us to our last visual encoding, which is the hierarchy of information. It is specifically important when you're building narrative structures and dashboards. There is a common reading pattern people have, and it's usually from left to right and top to bottom. Also, a quick share from user research sessions that I have done in the past. I have found out that people have easier time engaging with navigation filters that are placed on the left side of the page. Maybe there might be reasons, but it's usually very helpful to start from, building your interactions on the left, and then on the right-hand side, you have your visuals. Just as you use headings, you use, you use the same hierarchy, like in the HTML page, or you use headings, subheadings, body copy to give an idea about the hierarchy of the information, right? You can also use color, size, weight, position to convey certain hierarchy of information. You can say bold elements are a little bit you want to maybe surface your main KPIs in a very bold stylized way. It also helps audience to know where to look and gives them a space to explore. So since we are running from really behind, I'm gonna probably skip this example, but in your free time, and if you wanna again, I'm gonna type down my email address. You can create your own narrative structure with the visualization that you have. You can add different components, maybe different visualization, and just create a narrative structure and send it to my way if you want to. Of course, it's optional, no pressure. I think we have covered a lot of stuff right now, but we are still a little bit off behind. So do you guys want to take maybe 5 minutes of break, or are we good? Quick break, yes. Okay. So what we can do is, sure, okay. We can come back at 5, and we can start setting up the development environment. And while it's being set up, we can start working with the tools a little bit more. Yes.
Somebody asked to get your presentation. I normally do Google Slides so they can view it. Could you export it as a PDF and share it with them?
Yes, I will.
I think you should just do that if you have a second, so they can, because it might help them when they go through the next part too.
Okay. So
and you can actually send a file in the chat as long as it's not too big.
It's a little too big, I think, but I can send it to the mail.
Dropbox?
Oh, Dropbox. Okay. I think I
will. Or
find
Google Drive or something.
Yeah, I think I will find a way. In the meantime, let's take a few minutes break. Let's just come back at 5.
Okay, thank you.
wonder if it's gonna. Okay. Is everyone back? Great. Perfect. So I'm still saying we have a lot of material to cover. So we're gonna move a little quickly. We're gonna go ahead and start working with a environment setup. So I've included the instructions as clearly as I could, but since we're not going to be having a lot of time to troubleshoot, I'm also offering another option to work with Kaggle on browser. I included the different files that we're going to be working with. First, running Python and Plotly and Dash on your local computer. But also, like if you cannot for some reason for today, in order for you to still be able to practice, I also included a Kaggle code which you could work with. So let's just go ahead and first set up the environment. So what we're going to be doing, everyone is here, right? Hopefully. We're not going to know who's missing because they're not going to be able to. Okay, cool. So let's just like first, let's confirm that we have gone through the installation of Python. So if you're on Windows, you're going to go ahead and type right next to your Windows icon, search dialog box and type in command prompt. And if you are a Mac user, you can use your Launchpad and then search for terminal. And you're going to be seeing a dialog box like this, which is technically where we have a conversation with our computers. So it has a language on its own. So, but we're going to be working with like very basic things today. So you don't have to be like super knowledgeable. I'm not. So go ahead and write Python and make sure that you are seeing 3.8 version. If you are not seeing, like if you're seeing like 2.7 or something like that, just tell me and I will assist you later. Is everyone seeing 3? Okay, that's okay. Okay,
Yeah.
so.
Oh, sorry, just quickly. I'm seeing 2.7 as well, but I like installed 3.8 from the Python website. And if I type in like Python, I think it's Python and then 2 hyphens version, then it's 3.8.
Yes. So what we're going to do is that if you're seeing 2.7, I'm going to show another quick way to do it. But if you're seeing 2.C, 2.7, we can change the environment settings. Like we're going to do a little configuration settings there. But for the sake of today's example, we're just going to be, continuing with like simple steps. But if you're seeing another version, I'm going to help you while other people are downloading the other components. So, okay. So in order to see, okay, so quick thing. If you want to see where you are, like of course, like you want to like read into the files that we're going to be looking at today. So let me actually first show the file structure that we have. So if you unzip that folder, you're going to be seeing 4 different things. We have Plotly exercises. We have requirements that's going to have all these like libraries that it's going to install. We have Plotly exercises. We have, you know, like Kaggle code, local computer code. We have Dash templates, and we have some resources. So what we're gonna need for the initial step is that we want to read this requirements file. And even in the worst case scenario, if you cannot read and if you cannot troubleshoot, that's completely okay, because we have a Kaggle code that we can work with. Because we have a limited time, I'm just like trying to move things a little like faster. So we want to read into this like requirements file. So in order to do that, let's just first understand where currently our computer is reading the files from. So it's this path, right? So my workshop file is currently under my computer, and if I want to say list, which is ls means like list all the folders, directories that this path has, it's going to be showing all these different folders and directories. And what I want to do is that under this one, you can actually type in like change directory to desktop. Since I'm already in this folder, it's going to take me into the children folder. But you can also do this and write desktop. And then after that, I want to get into the workshop, right? Workshop folder. And then from here, I want to get into the requirements folder, which is O1_requirements. So I'm assigning a working directory. I'm assigning a directory that computer is going to grab files from. Is that clear? I hope that it's clear. So I'm inside the requirements file. So what I'm going to do is, in order to install all the dependencies, I'm going to use a very simple command, which is pip install /r, and then I'm going to type in requirements.txt. So in this requirements text file, we have all these libraries. Most of them are Dash and Python and Plotly components, component libraries. And I'm gonna hit enter. And you know, like it's mostly saying that I have all these like files, but probably for most of you, it's gonna start like downloading a lot of like stuff, which is what you should be seeing. Is that what you're seeing? Are you following me?
One thing you can do, I say, is to increase the text size of your terminal in the settings at the top. If you go preferences, because I always have to do this when I teach. It's under, I can't even see it.
Profiles?
Just click on all these things. Let me look.
Okay.
There it is. And you can actually change it to Comic Sans, which I did one time to make everyone laugh. So.
Okay. But we don't have time, you know. Or did I just-
You can make, I would just make the text size quite a bit larger.
Maybe like 48. I don't know how that's gonna
That
look.
might be really good. I don't know. Just try it.
Is there a save?
I don't know.
And I-
Try opening up a new window.
Um,
Command N and make a new terminal window just to see. You can keep that one open. Just do Command N when you're in terminal, and that'll open up a new window.
okay, this is quite
See?
big.
That's really big. But hey, it's super legible.
Yeah.
Yeah, I
Okay.
taught so much coding classes. Like at some point, I think I did a whole thing where all the students were like, make it pink and green and Comic Sans. Oh God, yeah.
Okay, syntax error, invalid decimal literal. Okay. Probably you have something going on with the date. So okay, let's just start from the beginning in order to see your current directory, right? So you are gonna say pwd and then change directory to whatever your folder is. Let's do it. Let's like move that over to desktop if it helps. I'm gonna do this one more time. And if it's not gonna work, don't worry about it. I think I need to like move a little quickly. That's why like I don't think I can help troubleshoot the problems, but we're gonna work with the Kaggle files, so you should be fine. Don't worry about like setting up the environment. You can always reach out to me later on if you want to like continue building things on your local machine. But for now, we're gonna be working with what we have. Since my file is in this one, I'm gonna go ahead and say requirements, text, hit enter. Okay, because I think I need to restart this one. It always does this. Okay, so let's try one more time. See the desktop. I know where my right. I'm inside that requirements folder. Now I'm going to start saying pip install. Can you see that? Pip install /r requirements.txt. Click enter. Start importing things. Perfect. Can you walk us through the steps again, please? I got lost in the process. Can you follow it, Ingrid? Is this only on Mac? This should also work for Windows. But this is actually what you should be getting. And if you want to check if your library is installed, you can also, in your command line, you can say import dash and see if it's working or not. Oh, it's gonna. Okay, Xcode. So I think it's a development. I think it's a Xcode is like a development. It makes things a little easier for dev environment. Yeah, building things in dev environment. I think it has like some package management components. Like I don't remember. But if you are not able to build that, we're going to be working with mostly the Kaggle files. that we have. And in order to do that, again, since we have a limited time, I had to come up with a lot, like different options, obviously. Maybe it's not the ideal, but let's just continue moving because we're gonna have a lot of stuff to cover. So let's just go to kaggle.com. And probably it's gonna ask you if you have an account, like you can just like easily sign up through different options, like either Google, Facebook, or whatever you have. And then you're gonna get into the notebooks and you're gonna create a new notebook. Oops. Even I'm getting some errors. Just gonna close this out. And we're gonna create a new notebook. Select language, we don't need to touch anything. We're gonna select Python. We're gonna select notebook. You don't need that. Click create. Now you have a notebook in your browser. So what we're gonna do is that we're gonna remove all these code and we're gonna be replacing them with the workshop files that we have so that we can exercise with them. And the way to, and obviously, like if you have started your local environment, that's great. I try to make things as efficient as possible since we have a like limited time. But probably you should be able to work from your local computer from there. But if you haven't, if you are not able to do that, you can open up this Python file. You can drag and drag that to your Atom, and you can see what it has. Like what is the content of this file. And what we're gonna do is we're gonna be like going ahead, and this is like line chart, but I want to start with scatter plots. Let's start with scatter plot, drag and drop, and copy everything from that file, come back to Kaggle, and then paste that into Kaggle. I'm going to be explaining all these, like what this code is doing. Oops. Also, you need to. Okay, so are you able to copy and paste? Like, are you following me? Like, just give me heads up if you are able to create a Kaggle and notebook. Is it straightforward enough? Which was the file that you copied? I'm gonna, so.
Can you just share the one you have with them? Because there's a share button right there.
Where is the one?
Up share on the top right.
Yeah.
And then I'm just wondering if you can make it public and then they can see it. If you make it from private to public at the top there.
Oh yeah, that's.
And then just copy that link and put it into the chat.
That's a great call out.
Yeah.
Okay.
Yes, sir. Because then they can copy and paste your code.
Yes. I can't open the scatter plot file. Okay, so can you open that notebook? Oh, you can also drag and drop that file into Kaggle, which is something that I did not know. Thank you. Without opening the file before on your computer. Yeah. That's a great call out as well. Thank you, Ligia. If I'm not pronouncing the link you shared is 404 for me. Okay, probably that's like something to do with Python. So this is, if you can link to this like Kaggle, you're going to be seeing the scatter plot, which is then we're going to be coming back to this, but which is like technically what we have to do it for now. I'm going to be like walking you through the code and what it's doing. But if you're able to connect to Kaggle, that link that I shared, then you should be fine. Is everyone set up with Kaggle? Can I see like comments on the chat? If you are able to see the notebook that I sent. Okay, this is a great way to really set up things without dealing with development environment, I guess. You can see my notebook. Okay, let's actually also to confirm people have done stuff. People can give a thumbs up. Reaction. For some reason, I'm not seeing your faces. Okay, I'm just going to copy and paste the code as well. So you can just like copy that one. Oops. Copy that one. And then paste it into a empty notebook. We're going to look into that too. Paste it. So are you like, just make sure that you're using the Kaggle one. And I think it might be missing one library that we can add. NumPy, I'm seeing it with like scatterplot, but we might have to call in NumPy as well. Google Colab notebooks. That's a great call out too. For future improvements, hopefully. Yeah, I think with you know, a lot of technical things that you have to consider when you have a limited time and when you're working with Zoom. A lot of things to consider. Okay, so let's just, we're gonna come back to Kaggle. But let's ensure that we have a notebook that we can work with. That's all that we are gonna need in Kaggle or in your local environment. Then we're gonna be like looking at different errors that you might be getting. So before getting into the Python libraries, I wanna give a quick, super quick, I don't necessarily think that I'm gonna have some time to cover all these things. But I also shared in that resources folder, you're gonna be seeing different tools. And you know, in data visualization, we have a lot of options in terms of technology. Some technologies are built on top of each other. You know, like when the level of abstraction increases, complexity and the design flexibility increases, but it makes them a little bit more, you know, like time consuming, like, because you have to like draw the line, you have to, you know, sort of define everything from the scratch when you have a lot of abstraction. And what I mean by abstraction is that when you're working with the code, mostly, if you're not like if you don't have a Plotly library, for instance, you're going to have to deal with a lot of abstraction because there is no framework that's built on something abstract. And, you know, like as you are moving into more like tools like Tableau or Power BI or things like that, you're going to have a lot of framework that you can easily build data visualizations and things like that. But I think one thing to consider is that you have a lot of options in terms of like where to draw your charts, but you have to be a little bit more mindful about like what tool is gonna provide what in terms of flexibility. I included like links to, I have a pretty long list that I included in terms of like tools that you can work with in this text file. So I'm not going to get into details, but like you have a lot of options if you want to explore. But today I just wanted to explore two specific browser-based tools to draw some quick sketches. And these are, you know, like before getting into like Plotly and like Dash, just starting with a little bit of a framework on the browser itself so that we are not necessarily like, you know, like just like putting ourselves into the water and trying to swim. I mean, that's that might be a good, like a different perspective of education, but let's just like start with practicing a little bit. So the first tool that we're going to be looking at today is in terms of, and of course, like, you know, I was meant to like share a lot of information about the tools and was going to get into details, but if you have any specific question regards to tools, I have worked with a lot of tools, I can say. I will be more than happy to help with you. You know, I have a lot of experience with Power BI, Tableau, R, and you know, like if I can help you understand like which tool is capable of what, I'm more than happy to do so, but I'm not going to get into details as we're running out of time. So the first thing that I want to do is that like, let's just open up this app that rovgraphs.io. I just put the link into the chat box. And they have a lot of samples that you can actually work with. So, you know, just for like 2 to 3 minutes, let's just like start building a quick visualization, quick interactive. This is going to be static, but quick static visualization that's going to be living on browser. So for my example, I used movies, try our samples. I'm using movies. This is a great tool, by the way, in terms of like providing options. You can like click on different visuals. It will tell you what it does, the functionality of the visuals, like the variables that you can work with, what are the things that you could visualize. It's just a pretty amazing tool that you can start working with. And I don't think you would need a lot of sophisticated tool if you want to build a simple story, right? So, and then I have this like data set, movie, genre, production budget, box office, ROI, and rating in IMDb. So I'm going to go ahead and select alluvial diagram for my own demonstration purposes. And I'm gonna pull in some, it's telling me what type of data I should be working with, right? Like it's telling me to work with either numbers, strings, or dates here. So I'm gonna put in ROI in terms of size, and I'm gonna put in genre into the steps. Oh, now I have a cool visualization. And, you know, it's just like easy. Like you can like change, like customize your visualizations and things like that. But as you can see from here, these are different genre categories. And it's pretty interesting that like the ET has the most return on investment. Like you can have a quick grasp of your data before even like, yes, I think like you can use those visuals. I think they can look pretty beautiful, and like you can create like SVG and you can customize this SVG code, and you can make a lot of like customizations to this visual. But it's actually pretty easy, you can also like read in your, like you can like use your own CSV file. Like I think you can use like text file as well. Like you can like play with it and like see your options. So for 2 minutes, let's just, try visualizing one of those things. Of course, you're not going to have time to explore. So maybe like just stick with like movies data and see what options that you can come up with. And you can, download this visual as a reference, as a practice. And you can also share it with me from my email address. So we're going to give like 2 minutes to practice with this one. Is that clear? Is everyone following me? It's just so hard to read the room. Yes, okay. Cool. Thank you. Thank you for helping me. Thank you. Yep, I find it very cool tool too. And I think like in the cool like tool list that I gave you guys, not cool list, tool list that I gave you guys, you can also like explore a lot of other cool tools too. What I'm going to show you is another tool. Yes, especially if you like, even if like, I do think that like the most important thing is that like, if you're not like visualizing, of course, like very early concepting, yes, but if you're not specifically dealing with a lot of complexity in your data, I think it's a very good starter tool. It's a very good like beginner tool. Like you can just like create simple visualizations. You can like create like a Medium article, put your visuals, put your photographs, support your visuals and things like that. And there you have a data journal of your own. You can like publicize it. You don't have to have like a lot of things. You just like need to be mindful of simple elements to play with. And then let's just look at this tool too before moving on with Python. Just keep doing this. So this is the browser version of like Plotly. So the Plotly and Dash is actually coming from the same company called Plotly, and they have like different products, but this one is specifically for building quick visualizations on browser as well. In the like sort of like advertisement of the workshop, I had this like visualization for California fires, and I just like built that with this tool, which was pretty simple. But I actually also included that file in the oh, I did not. Sorry, it's my bad. I think I overwritten. But I will send you that file. Okay. So this is a CSV file that I like that I worked with. I think I can send that to you. I put it on chat, but you can come to like Plotly, and like you can actually start, like you can import it. You can import your data set here, and then you can like, I mean, I worked with the density tile map, I believe. But you can, like choose latitude, longitude, your data types, and things like that. And like there is a lot of like customization options. You can like stylize them. You can come here, you can select your color scales, and again, here it's a bit of it provides a bit of a framework so that you don't have to deal with a lot of abstraction, if that makes sense. Is that cool? Okay, just wanted to provide some options that you can work with, and also like, like it has like some interactive components, like you can create some hovers and all these like different interactions, like zooms and zoom in, zoom out, and things like that. Select. So let's just start with talking about a little bit more. I guess we're not going to be able to practice with it a lot, but I still would want to explain the code structure a little bit more and help you familiar with the visualization libraries of Python in the last 20-25 minutes, if that's okay with everyone. So probably we're going to be like, from now on, we're going to be fully focusing on the Python and Plotly and Dash piece. Again, like if you have any questions so far, you can reach out to me, and we can talk, and hopefully I can give a little bit more background and topics that you have any confusions. So, okay, before getting into the practice, let's just ground ourselves a little bit more here. So we have some abstract libraries that we were talking about, right? Most of the Python libraries, I think I have seen one of you guys put that you were working with Matplotlib and Seaborn, probably all these statistical libraries that is helping you to come up with some like predictive models, right? Like more statistical, more sophisticated tools to understand your data, right? So Matplot is technically the foundation. And Python's visualization libraries are usually like technically they are modeled after MATLAB's visualization capabilities. They're highly abstract, but they have a lot of complexity. They can do a lot of stuff since they have a high abstraction. And then we have, like it creates these like static image files, and they're mostly like PNG, JPEG, so on and so forth. They're not interactive. Then we have Seaborn that is built on top of Matplot, which is making it a little less abstract, right? It has a less ambiguity, I would say, and it creates the specific purpose of the Seaborn libraries to create statistical plots. We can't interact with them in any way, and yeah, They are mostly for statistical analysis purposes. And then we have Plotly, which is technically, as I was saying before, it's a company, and it has a lot of like different tools. It is an open source interactive library, and it's not necessarily specifically for Python, but it has technologies for JavaScript, React, R, and the main functionality of these dashboards and tools is that Plotly usually, like the Plotly library itself, creates interactive plots as .html file. And then, but as you can see, you know, like it's not necessarily, this is also a static file. So the plot is locked, meaning that in order to generate new plots, you would need to, you know, keep generating new Python files and as you are working with the code. So you don't have an interface to like bring in all the interactive components that would manipulate your data. So Dash is technically solving for that problem. It's bringing in all these like Plotly charts, Plotly plots together, and it can, you know, like update, manipulate the data, and help, you know, like each components interact with each other. It's also, again, from an open source library from Plotly. It has like multiple components, you know, like, and it will produce a dashboard web application at your local URL. You know, and then you can just visit and interact with your dashboard. And you can also deploy them to web to share it with other people. I also included some documentation on this and put links in the folder on like how to deploy your web apps, like as you move further. But this is just like very minimal of like understanding like the code structure and like the syntax a little bit. But as you are moving forward towards building your own web apps, you can utilize that. So we don't necessarily have to know a lot of NumPy and pandas today, but still we're going to be calling them. We're going to need their help in order to generate and read data. You don't necessarily specifically worry about this syntax that we are using in our code. I just wanted to create, generate some data so that we don't necessarily spend too much time reading data. So we're going to be plotting scatter plot and line chart with within Kaggle. For most of the people, I guess that's the case. So in order to do that, we're going to be generating some numbers, like random numbers, so that we can plot them. But we won't have a specific data set that we're going to be working with, if that makes sense, for the sake of time. So you don't need to necessarily like worry about like the expression of this code, but in order to explain what, you know, like this is doing is that this 101 is just like an arbitrary number. It's just going to set up a seed, and, you know, like we're going to all have the same seed, so we can generate from the same seed, and we're going to be same list of numbers between 1 to 100 with 100 steps. So this is really generating that, you know, this is what it's all doing. It's just generating from that seed. So we're going to be seeing the same randomized numbers, although they're going to be random numbers. And then this is the code for reading from pandas. Again, we're not going to be dealing with this today, but it's good to know what expression to use to, you know, like bring in your CSV, read in your CSV files. What I would say is I think it will be helpful if you want to like manipulate, like as you are like moving forward, you're going to see that you're going to need a lot of like data manipulation. So I think you can always invest in some time in learning NumPy and Pandas, you know. I think there are a lot of like free courses and classes out there that will help you with that. So building visualizations with Plotly. So what we're going to do today is that we just want to really have tools to build visualizations. So I'm just going to show you how to use Python reference so that you can build on the example that we're going to be seeing today. So in here, we have the Python Plotly reference page where you can see a lot of like different examples, you know. And I think one of the main things that could be helpful here is that, where was it? I think we can just like go to figure reference. As you're working with different, you know, parameters, you can actually, you know, like if you're working with like color, you can see like you can look up the specific parameter, you can match it up to the plot type you have and see what options you have and things like that. And you can also look at like all these specific examples of, this is like, did I like open up the wrong link? Okay, yes, sorry, this was the right link. It's moved me into the next level that I was going to show. So you can see from here, you have a lot of like different options to work with, like animations, like crazy stuff that I have no idea how to create. So like all these like things that you can work with and like build on top of each other. And it has a great documentation. I think that's the beauty of like open source. You can just like click on it and see like it has a pretty like simple syntax that you can add things on top of one another, if that makes sense. And this reference is going to be like, this documentation is going to be like your right hand after some point if you're using this tool a lot. And then the second piece is that figure reference that I was showing, you know, I think if you have a specific component that you want to look into, you can just, you know, see, like use scatter plot, for instance. We're going to be plotting scatter plots and you have all these options. So let's just go ahead and start by plotting our first scatter plot. We have 10 minutes, so I'm just gonna probably explain only what the code is doing. But I just want to ensure, and I also want to like get into a little bit of like Dash and explain a few minutes of like Dash code structure so that you have familiarity when you're working with that, and you know, adding that as a toolkit. I have chat. Cool. Okay. So what we can do is we're gonna open up our Kaggle notebooks, and if I can get like confirmations that you were able to open up this from that, either from the link that I sent you, which I can do that again. Why did this like turn that into, okay, save please. Okay, so either from here or are you guys like able to like, were you guys able to open up this notebook for scatter plot? Yes. Can I get confirmations, please? Great. Okay, great, 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 great. And if you run the code, it's gonna probably work. But you don't have, like, don't do that, maybe. Maybe do. We're not gonna have some time to exercise, so you can just plot that. I'm just gonna explain what it's going on. Okay, perfect. So I'm just gonna go super quickly to explain what's going on here. So again, any sort of confusions, just either reach out to me or look into the reference or documentation. It's pretty clear and straightforward. So scatter plots. We're going to be, in the first example, we're going to be plotting scatter plots, which allows you to interpret, you know, like usually like it works with two variables. We have y, we have x. And it allows you to, you know, like interpret correlation most of the time. So in the very first place, we have the libraries that we're working with. We're going to be needing their help when we're writing the code with their modules. So again, in this piece of code, so this is the expression that I'm using in order to have you know, like Plotly visualizations in my notebook session. And then in this expression of the code, again, what I'm saying is like, give me 100 random integers between one, like, you know, like it's going to include 100 as well, 100 numbers. And then again, the same thing. It's going to be a matrix. And I'm gonna, I mean, it's gonna be, both of them are gonna be like separate arrays. And then after we generate this data, so as you can see, usually Plotly has separate components. So the first variable, and you just like keep pass on variables into one another. It's a little, it can sometimes get tricky, but I think like as you get familiar with it, it's super straightforward. First, you have your data variable. After you know, like you start generating your data, you have your data variable. So this is actually, so as you can see, we are calling in this subsection of Plotly called graph_objects as Go. So what this is calling, and you know, I think as you can see, like you can also, if you set up ADAM and if you like use like autocomplete Python, you guys are seeing my ATOM, right? It's gonna actually, you know, like after you type in this Go, it's gonna like show you different modules for that specific library you're working with. So for this example, we're working with scatter plots. That's why we're gonna just say, hi, give me scatter plot, geo.scatterplot, and I'm opening my parentheses. And we're just gonna say, you know, like x-axis is gonna be our random x array, and then y-axis are gonna be our random y array. And then we have this like mode, which is like, which you can also use in like lines, but it's it's technically saying like you can refer to the documentation, but as you are like working with like different stylings, but it's technically saying that mark that specific point in our scatter plot. So if we, and then of course we have our figure where we take our data and pass it into the figure that's actually, it's actually creating a figure object, and then that figure object is being called by a plot function that's technically gonna it's gonna first create the figure with these objects, and with this object, this is gonna plot the chart to our page. So if I hit and run it all, I'm gonna see this scatter plot, basic scatter plot. Are you guys seeing this one? Yes, perfect, cool. Clear, right? Cool. So I'm gonna go ahead and start adding, oh, I'm only having 5 more minutes, so I'm just gonna go super quickly. So if I just go ahead and comment out this piece and bring this one in, and if I do the same thing for this, oops, I always do this one. This one, what it's doing is that, like this is technically right now not giving me any sort of information. So data and figure is actually plotting the plot. But when you describe all these layouts, right, like when we were talking about like giving more descriptions and details and things like that, that's where layout is going to come handy, right? Or when you are placing your objects. So in layout section, the difference between data and layout variable is that with data, you're going to start with a squared bracket. With layout, you're not going to have that. You're going to start, again, type in graph objects dot. Whenever you're going to start typing layout, you're going to see this one is going to come as well. Obviously, it's a pretty common module. And then you can give some give title, x-axis, y-axis, and hover mode. So in here, I mean, there is a, dictionary values and things like that, where you can actually have a different sort of syntax in order to give title to these random x values. But we also have a function to make things a little bit more clear here. You have title, you have your x-axis have a title, your y-axis have a title, and then you continue defining all these different components of your visualization in a sense. So let's just go ahead and run this. Now I have a title, random data scatter plots, random y values, and random x values. So we're getting closer to time, but just quickly as an example, you can also run, this is literally the basis. You have data, you have layout component, you have figure, and then you're going to be plotting that figure. It's just passing one object to one another. That's what it is. And once you start figuring things out, it's just going to be coming super easy. But let's just go ahead and work with this line as well, because it's going to be a little different. And, documentation is going to be coming handy as well. Oops, I wonder it's going to work out. I think I included a lot of stuff here. Let's see. Oh, I want to do this. Okay, so this is an example with 3 line charts, like a combination. But with line charts, it's what you're gonna do is that instead of like, like defining data, you're gonna be saying you're gonna be defining traces, and like this is like a multiple traces example. Again, all of these traces are calling go.scatter, because actually line is a scatter with just line segment instead of like all these markers. So as you can see, when you like define like modes, right, like you can have like marker with lines, you can have like just lines, and you can only have like markers, and obviously let me just like give a little bit structure here. Since we're running out of time, I want to be mindful of like everybody's times. Like, do you mind if we like go a little bit further, like maybe like 5 to 7 minutes more, just to give you like help you understand like what this code is doing? Fine? Is it okay? Okay, and I just want to quickly show you like the Dash structure as well. And thank you for your patience and understanding as well. I tried to like share as much as I could, but there is only too much time, you know. Okay, so let's just like break down into this one into the segments as well, because I think this is going to be helpful too. Again, what I'm doing is like I'm generating some random numbers from that seed. This is like pretty similar to the first example that we have seen. It's creating 100 evenly spaced values and 100 random values. And then, so for, I think, Plotly, every trace is going to be placed in that data variable as components of lists, because it's technically creating this like sort of a list instead of like separate data points, right? So first you have to build all these like traces and put them in an array list of sort of like objects in a sense, in order to combine all these, like create all these like combinational effects. And then what we're gonna do is, what it's doing is that it's creating all these traces, and like it's adding in like +5, -5, so that they're not like on top of one another. It's creating and then like it's passing these traces into this data variable, and then it's this layout, it's creating this layout, and then the figure is reading data and layout, and then the plot is plotting this data. So again, working with the references is going to be pretty handy. I want to quickly touch on Dash as well, as it's important too. It has, I just want to show you from here, actually. It has like 2 parts, where it has like layout, where it describes what the Dash itself is the application, right? Where it's technically a full web app, interactive web app. And this is like from one of our example, but I'm not gonna get into detail too much. This is a little bit of like more like stylized thing, but it's very simple at the same time. For Dash, you can also see like templates, and I can help you set up that Python environment later on, local environment later on. I can help you troubleshoot if you want to build that, and if you troubleshoot that, and if I have a problem, you can reach out to me. We can like block some time, maybe like next week or so. I'm not sure when that will be, but I can help you like set up and get you started with Dash app in your local environment. But for today, what I can say, let's see this one. We have first the layout, and we have the callback. And under layout, we have all these different components that you can actually refer to. And Dash also has this like amazing documentation page where you can like look into different like options in order to create some interactive components. And like what I have done was technically just like I like mostly created our like 2 examples from here, and I put it in a file. It's pretty straightforward. What it's gonna do is that like you have this like Dash component, core component. You're calling this one. We have already imported that one. You're creating this slider, and slider usually have this like minimum value, maximum value, and it has like some steps in between them. And this is like this value could be, I think value could be a little bit tricky where you might have to do a little bit of programming there. But it can have like one arbitrary number. So you can build all these like components, and then like start like building things on top of one another, I would say. And then of course, like in order to build interactions between them, you're gonna have to refer to callbacks. So layout, core components, and callbacks are 3 important things in Dash. I said 2, I guess. But yeah, first you have layout, then you have interactivity, and under interactivity you have like callbacks and core components. But the documentation is there, and I hope that this is this is enough to help you start it. And I think this is it. And I can stay if you have more questions. And
Thanks, I say. I just put the link in there. You guys should grab this link now because it's an unlisted link to the YouTube live stream recording of this workshop in case you want to go back and you missed something that Isay said. You have all the files now. You sent the deck, like you have everything, so you could always like watch it again.
Yep.
Thank you. That's so complicated. It's like I'm very impressed with your job now. Like, wow.
I tried to make it a little more like clarifying.
It's a lot.
It's a lot. It's a lot to cover.
And it's a lot of different like tools and stuff because I don't really know data viz in that way. I mean, I learned design and I know code, but it's a bunch of different tools, and it seems like there's a lot of different ways to do similar things and a lot of tool sets. Yeah, you covered a lot. It was a great overview.
Yeah, and hopefully like you can just go back to your resources and you can revisit them. And if you have any questions, like feel free to reach out. I will be happy to clarify. I will love to like make myself accessible. I would recommend using processing for data visualization, and I have a great course suggestion from Nicholas Falteran, I think. But it's mostly for data art, I guess. It has like more generative sense in that sense. And I think, Nikki is teaching like P5 and processing, and I think she could be a great resource in terms of like maybe leading you towards that, towards those things. I'm not a developer.
You can use processing in P5. It's unlike the way that some of these tools are set up directly to do plotting and mapping. There's going to be more like not jury rigging it to make it work for you. There's going to be a little bit more. You'll have to use all other people's probably code to kind of like create some of the framework that already exists in like this Plotly or whatever stuff you've been using. And I just put a link in here into the chat. Me and Ice are both on this. This is our confederated chat server. You should have got a link to this when you signed up for the workshop. And if you sign up for it, then you can like chat with us. It's like Slack, but it's open source. In Gray Area, we run our own server so that it's encrypted as well.
Yep.
Keep us safe from the powers that be. Anyway.
You know, like we can maybe create channel from there and we can continue this like community feeling.
Yeah, I can make a DataViz room right now and share the link.
So, you know,
I'll make one right here. Just 1 second. I'll make it. I'm going to call it DataViz.
And we can continue having chats about like data visualization, the sources that you're exploring. And I would love to see your progress. I love learning, but I also like, I'm starting to realize I love sharing more than learning. So seeing your process would be very,
yeah, I
yes,
see. Didn't you send it already?
I did, but I can send it again.
Yeah, so that link I just sent you guys, that is the new DataViz room I made. And you can click on there and join the room. I'll invite Ice right now. And I'll invite Steve because I know him because he's in this class. And Ice and Steve are both part of our incubator. So Steve has taught projection mapping as well. And yeah, I encourage you guys. Maybe this month or maybe next month, there'll be an artist salon where they talk about their work they're doing. So stay tuned.
And yes, so I think that's it for today. Yeah, I would love to see your work too, maybe someday. I couldn't put a lot of faces on your names, but it was beautiful to interact with you even in this way. And I shared with that, and I think Nikki, if you can take out that question, how like matrix, yeah. So
yeah, so you can move that link I just sent. That I'm sending one more time is the link to join the room, the DataViz room, and our chat server that's like Slack. So yeah, you guys should join the room because you can talk to us.
Yep.
Ask us your question, burning question.
Okay, so I think this is it, right? Do you have any
Yeah, this is it. And we're at time, so let's move the conversation over there. In your emails for this workshop, there's also a manual that I sent you about how to join the matrix thing if you're confused, because it's super confusing. So anyway, thank you. We have 2 more workshops tomorrow. We have one about processing and looping GIFs. We have one about what is it called? One about with Art5 about augmented reality, which still have some room in them. If you want to join, go to grayareafestival.io. You can join those workshops. And that is all I have to say. I'm going to end our broadcast, and we will